State two characteristic properties of metals. So any two would do. So for example, you can have high melting point, good conductive electricity and heat. Those are two of the, I guess, the most common ones. But anything else would work, ductile, that sort of thing. Acids are used to make salts. Give the name of the acid used to make chlorides. So if you remember that sulfuric acid produces sulfates, nitric acid produces nitrates, so hydrochloric acid, that's the only other one you need to know, the only other mineral acid you need to know, that will produce chlorides. Salts of metals can be prepared by reacting the metal with an acid to produce salt and hydrogen. Describe the test to show that the gas is hydrogen. So if you remember, with hydrogen, you hold a lit splint to the mouth of a test tube that contains the gas and you'll hear a squeaky pop. So what you write is, apply a lit splint, squeaky pop. That's it. You literally just say what you use and what you'll detect. A bit like the carbon dioxide test using lime water. Use lime water, turns clear to cloudy. Next. Nickel is a metal. Explain how the structure of a nickel atom changes when it forms a nickel ion. Right. Now it tells you that a nickel ion has a 2+ charge. So if you want to take a real shortcut, all you have to understand here is to gain a 2 positive charge, then it must have lost 2 negative particles. So 2 electrons must have been lost from the nickel atom. But to give you a bit more understanding, this is what a nickel atom looks like. You have 28 protons because it has an atomic number of 28. You can look this up in the periodic table at the back of your exam paper. And 28 protons, and therefore the atom will also have 28 electrons. Now I've distributed these around in the shells, 2 on the first shell, then 8 on every other shell until I get to 28. When I do that, I realize on the outer shell there are 2 electrons. Now what an atom will achieve is a full outer shell when it reacts. And there's 2 ways an atom can achieve a full outer shell. One is it can gain electrons, or it can lose electrons. Now, it will take the path of which is least energetic. So, for example, this one, does it take more energy to acquire 6 electrons or simply lose 2? By losing 2, you basically end up with a full outer shell underneath. So you can see now that I've got a full outer shell of 8, having lost these 2 electrons. But as a result, because before there are 28 protons and 28 electrons, okay, now there's 28 protons and 26 electrons. There's 2 more positives and they're negatives. So we have Ni2+. So that's perfectly good for foundation level and higher. But if you want to understand it in another way, you can express your answer as a half equation. So the ionic half equation is as follows. You start off with a nickel atom, and then after it ionizes, when it forms an ion, you produce a nickel ion and 2 spare electrons because you've lost those electrons. So that's what you end up with when the electrons dissociate from the nickel ion or nickel atom to form that nickel ion. So remember, this is an explain question. So we have to say it loses 2 electrons for 1 mark from the outer shell. So that is where the other mark comes from. So it's really easy to answer, and there's a lot of understanding behind it, but you need to be able to understand it to actually answer it so simply. So it loses 2 electrons from its outer shell. That's how its structure changes. So the structure means you're talking about shells, and the reason why it acquires a charge of 2+ is because it loses 2 electrons. A nickel sulfate solution is made by dissolving 23.5 grams of nickel sulfate to make 250 centimeter cubed of solution. Calculate the concentration of the solution in grams per decimeter cubed. So firstly, always highlight or underline the different things you have. So you've got 23.5 grams, that's mass, and you've got a volume, 250 centimeter cubed of solution. So the concentration is worked out by dividing mass by volume. You'll need to remember this. It's not given to you as a formula. So mass divided by volume is concentration, because concentration is how much matter there is in a 3-dimensional volume of liquid. There's one catch here. It says calculate the concentration in grams per decimeter cubed, not centimeter cubed. So that's a bit tricky because you have to do unit conversion. So this is a centimeter cubed, where every sort of dimension is 1 centimeter to make a cube, but a decimeter cubed is basically 1,000 of these in a big giant cube, because you have 10. So 10 of these, imagine it's going down to 10, 10 along here, 10 deep as well. So you're doing 10 times 10 times 10, which is 1,000. So it's 1,000 centimeter cubed. So you have to do a conversion because they must be alike. So that's the catch. So firstly, to convert 250 centimeter cubed to decimeter cubed, just whenever you're doing a unit of conversion, do this. If you find them a bit tricky. Some people are very good at them, but if you don't find them easy, don't worry, just do it like this. So you've got 1 decimeter cubed equals 1,000 centimeter cubed. That is a fact. You always do from 1 to 1,000. So to change 1,000 centimeter cubed to 1 decimeter cubed, you divide by 1,000. To change a decimeter cubed, 1 to 1,000 centimeter cubed, you times by 1,000. So in other words, to convert to decimeter cubed from centimeter cubed, you just divide your number by 1,000, and to convert the other way, you times by 1,000. So what are we trying to do here? Well, we're trying to convert from centimeter cubed to decimeter cubed. So centimeter cubed to decimeter cubed, we divide by 1,000, and when you do that, you get 0.250. So we just divide that by 1,000, so that's 0.250. The rest is easy, we're just substituting the figures in. So mass is 23.5 divided by 0.250 equals 94 grams per decimeter cubed. Oh, I forgot to write the little minus there. Excess solid nickel carbonate is added to dilute sulfuric acid in a beaker. Here's the chemical or the word equation. Nickel carbonate, sulfuric acid, these are the reactants, produce nickel sulfate, carbon dioxide and water. Of course you get carbon dioxide because it's a carbonate. Nickel sulfate is formed in solution. Describe how a sample of pure, dry nickel sulfate crystals can be obtained from a mixture of nickel sulfate solution and excess solid nickel carbonate in the beaker. This sounds really, really complicated, but keep it simple. When you see these words in a question, describe how to make a sample of pure dry nickel sulfate, pure dry salt. Effectively, you're going to be saying the same thing every time. You just need to adjust the context for the chemicals they give you in the question. So let's just unpack this question. It says excess, that means plenty, more than you need, solid nickel carbonate is added to the dilute sulfuric acid. So what that means is all the acid there'll be enough acid to react with as much nickel carbonate as possible, but there'll still be some solid nickel carbonate left over which hasn't reacted. That's why this is excess. So in other words, you'll have kind of the Goldilocks amount of this. You'll have the perfect amount of sulfuric acid in the reaction, but you'll have too much solid nickel carbonate. So what you're going to end up with is a mixture of nickel sulfate, which is what you produce when you react these two together. So you'll get nickel sulfate, which is what they've said over here, and you're going to get extra nickel carbonate, which hasn't reacted because the acid ran out. The acid is the limiting reactant here. So how do you separate, basically, what we've got here is a solution, or a mixture rather, of nickel sulfate here, and then you've got your solid lumps of nickel carbonate, and you want to separate a solid from a liquid and then prepare a pure dry sample of this salt. So we want to, this is a salt dissolved in liquid, and not the black thing, ignore the black thing, we're talking about this bit here. This is a salt over here dissolved in liquid, so we'll need to evaporate the water from here, because you can see there's water in this reaction, evaporate it to leave behind the salt crystals. So the first thing you do is you use filter paper to separate the liquid from the solid, so the solution will come through, and then use an evaporating dish, evaporating basin. You heat it gently to basically evaporate the water, and then you allow until nearly all the liquid's gone. Then you just allow it to dry. You can also pat it dry. So filter, 1 mark. Perform crystallization. That's what this process is here. When you're evaporating stuff, you say perform crystallization, but you could express it in other ways. And then By heating, filtrate till concentrated and leave to dry. So this is called filtrate. What you get at the other end of filter paper we call filtrate. So by heating this filtrate, or by heating it till it's concentrated, so this basically is just a real thick soup of nickel sulfate, which just a little bit of moisture in there, and leave it to dry because it'll be warm enough now for the water to evaporate without damaging the salt by excess heating.